Yeah, am I audible, Deep?
Yes, sir.
So if there are any doubts, you can speak up.
Sir, my doubts are cleared yesterday.
Okay, so I got a bit late. I was giving the exams. So it's over now.
So what?
Okay, so let's wait for 2 more minutes before everyone joins. 12 to 6. Okay, so were you able to solve this one?
Yes, sir. So second one is the stable one. The down bottom one.
Okay. Okay, so this is the algorithm for checking whether things are stable or not. Okay. So today we'll have a short class because of some other issues. Okay. So what is J? What is J called here? J is called the
Imaginary.
J is not the imaginary. J is the
Moment of
moment of
inertia.
inertia.
Oh yes, a moment of inertia.
Yes. So we'll take on these things later. So first of all, you should remember the four quadrant operation. Four quadrant operation mm,
Of chopper.
of any converter, not necessarily of chopper, but of any converter. Say, for example, it's a four quadrant chopper, right? But it can be because of dual converter also, right? So what was the issues for the four quadrant chopper action? In the four quadrant chopper, we have the first quadrant as power is V into I. So Deep, can you mute? It's too much
Okay,
of
sir.
noise. Okay. So four quadrant of chopper has the first quadrant as positive power. So because it is positive power, that means the energy will flow from the source to the load, right? So in the second quadrant, what is this? In the second quadrant, the power is negative, right? This is minus I. So that means power is negative. That means it is flowing from the load to the source. So we call this forward regenerative braking, right? Regenerative. We call it forward regenerative braking. Don't fix your ideas on the quadrants. First of all, see what are the axes, whether it is voltage or current, and then see whether what kind of converter is there, whether it is four quadrant chopper or it's a dual converter. First of all, see that, then only you can judge whether it is regenerative braking or forward motoring mode, right? And then this is the reverse motoring mode, the third quadrant, where power is a product of minus V into minus I, that produces positive power. That means source to load is going. So this is reverse motoring mode, right? And this is reverse regenerative braking mode. Why will you call it regenerative? Any idea? Because during this time, the motor is acting as a generator and it is generating power. That means it is regenerating power. Regenerating power, right? So that's why it is called regenerative braking. So once that motor used to take power, now it is generating power. So it is regenerating power. Okay. So a classic example of a 4-quadrant operation of a drive is in a lift, right? So can you just decode all this slide, how it happens in a slide? So we have some languages over here, that is empty cage, the weight is WE. Where is the empty cage? WE. So this is the cage. This is second. This is the cage, right? Where people or some goods can be there. So I have this empty cage of thing right now at the back of my building. So the construction items are keeping on constantly going up and down in this. So the loaded cage is here, and there is some counterweight. So why do you put some counterweight? Have you seen some counterweights operating in a lift while it is running?
Yes, sir.
So there is some counterweights to balance this thing, right? Now, if there is something other weights, then the motor will take care of that, right? So first of all, see whether, so here the power will be given as power equals to torque into speed, right? So we have to look at this torque into speed thing and detect whether it is regenerative or motoring mode. So first of all, in the first quadrant, we will see it. So see, when the loaded cage is moving up, right? So you have loaded the cage with some bricks or this and that, or some people are in it, and it is moving up, and the counter weight is there, but still some more weight is there, right? So what will be the natural tendency of the cage, to go up or go down?
Sir, if it is less heavier than the counterweight, then it will
See,
go
the
up.
counterweight is almost as equal to the empty cage, right? So it is just there to counter the weight of the empty cage almost. So like that. So what will happen then? If some say this is 100 kgs and this is 100 kgs, and sorry, this is 110 kg with the person. So
See,
tell
it
me,
won't go up.
it won't work. So where will be the load torque? Downside or upside?
Load torque will be down,
what
down.
will what will be the natural tendency of the load of the cage? To remain at ground only, right?
Yes, sir.
So you have to pull it up,
Yes,
right?
sir.
So if you have to pull it up, you have to rotate the motor anti-clockwise,
Yes, sir.
and the generated torque, that is Tg, will be in this direction only.
Yes, sir.
So the power will be positive torque and into positive speed. So what will be that? Power will be greater than 0, right? See, anti-clockwise we always think it is positive, right? Clockwise is negative, anti-clockwise is positive. So this is the convention. Not any reason is not there, but it is a convention that anti-clockwise we will consider it as positive and clockwise as negative, right? So anti-clockwise, see, both are anti-clockwise in the first quadrant, right? So this is the TG, this is the rotation, the direction of rotation. So are they both anti-clockwise? Yes or no? Yes.
So TG and TL are in opposite
Yes,
direction.
obviously, because you have to pull it up, na?
Yes,
If you,
sir.
if it was a well, if it was a well, a water well, so what would you have done? You would have pulled that bucket up, right? So and the bucket would try to go down, and you would try to pull it up, right? So what is
Yes, sir.
happening? So both are positive. That is, the power is positive. So it is called forward. Why forward? Because it is anti-clockwise. Right? Anti-clockwise is considered as positive. Forward motoring. Is it not so?
Yes, sir.
Okay. So now let me get rid of this. Okay. So now coming to the second quadrant. In the second quadrant, you have an empty cage sitting idle in the but it is sitting idle in the ground. On the ground, it is sitting idle, right? So let its weight be 80 kgs and this is 100 kgs. So what will it try to happen? What will try to, the counterweight will try to go down,
Yes, sir.
right? So what has the motor to do? The motor will try to do what? The motor will try to keep the,
Keep the lift down only. So
no, why will it try to keep the lift down? Once you press the lift and see if there is a no control mechanism, what will happen? The counterweight will fall down rapidly, right?
yes, sir. So it will make it
It will make it
go.
go very fast, higher. The empty cage will try to accelerate upwards fast, right? Because
Yes, sir.
extra 20 kgs are there on the left side, right? So what the motor has to do in order to keep the cage going up at a lower speed, what does it have to do? It has to operate in the other direction.
Yes, sir.
Say on the left side, just a second. So on the second, say it is trying to down, right? Now the motor has to pull it up, has to make this movement, right? Need a feedback.
Yes, sir.
So what is the direction of load torque? This is the direction of load torque. So it is trying to pull it down, but the motor has to keep it up, right?
Hmm.
Else
Yes,
the
sir.
empty cage will accelerate upwards at
Yes, sir.
higher speeds than it is desired. So what will happen to the person? The person will fade. Right. So this is now that TG is now clockwise, so it is negative, and the speed is what? Still it is clockwise. Why? The counterweight will go down, right? So the motor is being driven by the counterweight. Is it not so? The speed of the motor is governed by the counterweight, but the torque is negative, so as to slow it down.
So torque is generated torque in the in suppose right hand side. So the speed will
See,
the motor will
talk in terms of clockwise and anti-clockwise.
okay. The generated torque is in clockwise direction. So
No,
rotation
wait.
will also
Be slow, be slow, be slow. Tell me.
generated torque generated torque which is in clockwise direction. The it will
Yes,
make the motor to rotate in clockwise direction. Being it slow.
yes, yes. It will try to rotate. It will try to rotate. Say, just let me take
So
a separate window.
TG and
Just a
WM are
second.
same
Just
in
a
same
second.
direction.
Just a second. You will understand. Just a second. Say this is the pulley, right? This is the prime mover. The motor is attached here with the shaft, right? Now, when this is say empty, say 10 kgs, and this is 100 kgs of the counterweight, right? Now, what is happening? If you do not restrict this, what will happen? It will speed upwards and it will speed downwards, right?
Yes, sir.
Now the motor has to provide a opposite torque or not.
Yes, sir.
So the torque load is TL negative and the TG is clockwise. So if the TG is clockwise, TG is negative, right? Now what is happening? If you are saying that okay, the motor should rotate in the direction of
Clockwise direction.
TG, then what will happen? The cage will go up or down. The cage will remain at the ground only, no?
Yes, sir. That
So,
is what we are trying to do, na?
no. We are say you are in the fourth floor and you want to go down. So what will happen? You are in the fourth floor. and you have to go down. So you will order the cage to come up.
Okay, yes, sir.
So do you want the cage to come up at 50 meter per second speed? No, na?
No,
So
no.
you want the cage to come up at a reasonable speed, right?
Yes, sir.
So the cage has to come up. So that means the motor has to rotate in this way only, but at a reduced speed.
Yes, sir.
If the TG was not there, then the speed would be huge, say 50 meter per second, and the cage would drastically have an accident upwards, right? So the speed of the motor has to have this clockwise, sorry, anti-clockwise. So the speed of the motor is anti-clockwise, so it is positive, and the torque of the motor is what?
Clockwise.
Clockwise, so it is negative. Do you
Sir, but
understand
it is,
this?
sir, but it is becoming like it's application specific.
Yeah,
Suppose
it is a application specific of a lift only, and the lift is everywhere almost. So it's a
no,
very
I'm
common
telling that
application.
if the person is not at the fourth floor, then the speed direction will be in opposite direction.
Yes, so we will consider that case also, na? In the other quadrants, we will consider that case also. Don't
Okay,
worry.
sir.
Right.
Okay,
So
sir.
this is so ultimately the person can be either in the ground floor or in the fourth floor. That is the two extremes, right?
Yes, sir.
For our building, right? So
Yes, sir.
we are considering this only. So the speed of the motor has to be anti-clockwise, else how will the lift come up, right? But if you're not having this TG thing, this TG, then the lift will come out up at a huge speed and it will destroy, right? So that speed of the empty cage has to be lowered by adding this TG, right? Got it? So the net torque will be TL minus TG. The net torque acting on the ropes will be TL minus TG. If TG was greater, then the motor would have rotated clockwise. So TL is greater than TG here. But for the motor part, the TG is negative, but the motion of its prime mover of its shaft is positive. So what is the power? Torque into, so it is negative torque into positive speed. So what is that? Less than 0? Is it not so? Any doubts, please come up. So the power is less than 0. What does it say? That it is regenerative braking, right?
Sir,
Yes.
so torque is applied in certain direction and the motor is rotating in other direction. Sir, don't you think it is violating its own principle?
No, why will it violate? Why will it
I mean,
violate?
torque is applied in certain direction and motor is rotating in other direction.
Huh? So it happens now. You are not okay. The motor is being forced to rotate in the other direction. Got it?
Oh, yes, sir. Yes, sir.
The
Motor
motor
is
is being forced to rotate in the other direction by the counterweight,
okay. Yes,
but it
sir.
is trying to have a reverse torque. And what torque is responsible for this?
TG.
TL.
Oh, yeah. Yes, yes, sir. TL.
Just a second. Just a second. It's very interesting. It took some time for me to understand in my days. It was very interesting. So see, there is a huge load, 100 kg, right? And you have a empty cage has a 10 kg is the weight of the cage. Now this 100 kg wants to go down, right? But if
He
you
will
keep
go
it
down
free,
forcefully.
yes, if you just leave it like that, it will go down at a high speed, right? And what
Yes, sir.
about this empty cage? It will just jump up, right? You
Yes,
don't
sir.
want this sudden action, right?
Mm.
100 kgs, just imagine 100 kgs of weight falling from a fourth floor. What will happen to the ground? Things will break,
Yes.
right? So what that motor needs to do? The motor needs to have a reverse force. It needs to try to rotate on the reverse side. So TG is this way and TL is this way, right? But obviously TL will be greater than TG, such that the speed of the empty cage is reasonable, right? It is tolerable, right? So that is why it is rotating in the direction of the counterweight. So it is omega n. Now do you understand it?
Yes, sir.
Yeah. So power is negative torque into positive speed. So that becomes less than 0. That obviously is regenerative, not writing. Okay, regenerative braking. So just feel the thing. Whenever you are in the fourth floor and you are trying to bring up the empty lift, you are actually making the lift go into regenerative braking mode. Got it?
Yes, sir.
Okay. So let me have the screen cleared. So now you are in the, now say you are in the for ground floor, right? So some people are in the ground floor and the lifts needs to come up. Just a second.
Third quadrant.
Yeah, in the third quadrant, third quadrant, the case is you are in the ground floor, right?
Yes, sir.
And you want to go up, but the lift is in the fourth floor. So what do you want? The lift to come up, to come down for you?
Yes, sir.
So you order that you will go up and the lift is coming down. So what do you think about this weight? This weight will oppose or not? This weight will try to remain downside only, na?
Yes, sir.
So what will happen? This will be the value of TL. That load torque will be downside,
Yes, sir.
right? And so the motor has to generate an opposite torque TG, which is greater than TL.
Yes, sir.
So it will try to pull this weight and it will try to make this weight go down. So what is the direction of TG? Direction of TG will be anti-clockwise.
Yes,
Sorry,
sir.
the why what? Yes, sir. The value of TG will be negative, no? It is
Yes, sir. So
clockwise.
that's what you are telling, na?
Clockwise.
Anti-clockwise. It is right only.
This is clockwise. This is clockwise.
Yes, sir.
So this
Clockwise.
is clockwise.
And the
So
direction of motor will also be in clockwise.
yes, if it is not, then the empty cage will not come down, right? So it has
Yes.
to apply a torque TG which is greater than TL, right? So it is trying to pull up the counterweight. So direction is also clockwise, so it is negative. So the power is negative torque into negative speed. So that is obviously greater than 0. So what will you call it?
Reverse motoring mode.
First of all, it is motoring mode, right?
Yes, sir.
Now, because it is clockwise, we will call it negative or reverse, right? So
Yes, sir.
if the direction of rotation is clockwise, we will call it reverse. If the direction of rotation is anti-clockwise, we will call it forward, right? Or positive. Now coming to the last one, where you have a loaded cage on the fourth floor. So after the class, some students are in the loaded cage and they want to go down, right, in the ground floor. So this is the case at 5 p.m. Mostly this is the case at 5 p.m. People at the fourth floor, they want to go down, right? So what is this case like? So where is the load torque? So the load torque will try to what? Say the load. Actually, yeah. So the load wants to go down TL, right? Which is TL, actually TL say the loaded cage is 200 kgs, right? And this is only 100 kgs. So what will happen?
It will try to go down abruptly with a
So
bump.
all the students will try. to go down, it may seem that they are trying to fall down, right? So what will happen, that motor has to pull them up in some way, but
Yes,
it
sir.
will obviously create a force that is less than Tg, less than TL. So T generated will be less than TL, so that they descend slowly, right? Let me go to a white screen. Okay, so at 5 p.m., it's 5 p.m., and some students are happily got into the cage, and they have ordered that they want to go down. This is the 100 kg weight, and they want to go down from the fourth floor. So along with this, this is at 200 kgs. So the people here will tend to fall down immediately if there was no motor, right?
Yes, sir.
Now, so the load torque direction is this way, right? And the direction of motor has to be this way only,
Hmm.
sorry, clockwise only, right?
Yes, sir.
If then how will they go down, right? But if you if you do not pull this 200 kg, this 100 kgs extra on the right hand side by the motor, then what will happen? It will be a high speed downwards, right? So the motor will have a torque generated in the anti-clockwise way. Is it okay now?
Yes, sir.
So the power is equals to positive torque. This is for the motor side, right? So this is for the positive torque is there because it is anti-clockwise into negative speed as it is clockwise. This is clockwise and this is anti-clockwise, right? So the
Yes, sir.
motor wants to make its shaft go anti-clockwise, but due to the weight, it is being forced to rotate clockwise, right? So what is this? Less than 0. So this is what? Regenerative braking. But what? The speed is negative, so we will call it reverse. In the earlier case, it was, this was forward. Why? This was forward because the speed was anti-clockwise. So it was positive speed. So it was forward regenerative braking. And this is, the speed is clockwise. So it is reverse and power is negative. So reverse regenerative braking. Is it clear?
Yes, sir.
So any doubts from anyone?
Sir, what would be the initial weight of that lift? Not counterweight, that lift which is moving up and down.
Loaded cage.
No, no, neither loaded nor empty. I mean, initial, only its weight, its body weight, its body weight.
See, does it really matter? Does it
Yes,
really matter? What
because
matters? What
because the
matters?
weight of the load is only causing it to move up and down, na?
Yes, no, the weight of
So,
the difference in the weights is causing, not the weight. Say this is W1, say this is W2. If W1 is equal to W2, they would have been hanging in somewhere this way only. So there will be no movement.
so initially when we make it
See, what is the
W1,
condition initially? What do you mean by initially?
I mean, when no load is applied, only its body weight is working.
No load
No
means the
load,
empty cage, right?
empty cage.
Empty cage, right? So
Hmm.
tell me, what
I
would be
think
it?
I think that empty cage would be
Somewhere
less,
nearby?
always less than counterweight.
Yes, definitely, because this is a lift meant to operate, right? So if someone is here, then it would be easier for the counterweight to have a balance. Say two
Yes,
people
sir.
are here or one people are here, right? So this is say 100 kgs, this goes to around 150 kgs. two two people of 75 kgs each, right? So what would be the thing? It would be 50 kg extra. So it will try to go down. It will try to
Yes,
go
sir.
down, right? So the motor has to pull them up, right? So this would be the case for the first quadrant. So it will be, so it will say two persons are here, seven, sorry, 150 kgs. So it will try to go down. So the load torque is downside. So the motor has to pull them up. So the value of TG is positive and the motion is also positive. So this is omega m. So it would be consuming power. Is it okay?
Yes, sir.
So whenever you're taking a case, always go for the extreme values. So your design will be as within these limits, right? Okay. Okay. So there are so this just a second. Yeah. So equivalent inertia and load torque of different coupling mechanism. So we'll be going into depths in the next class for this. For today only, we will discuss the amount, the different types of mechanisms for interfacing the load and the motor. So earlier one question was asked that if it is a motor, say it is running at say 350 RPM only, but there is a fan and the fan needs to rotate at 3000 RPM. So what do? You have to attach this fan to this motor. If you directly if you directly attach it, then what will happen? It will rotate at 350 RPM only. How will you get 3000? Say it is we want a 3500 RPM speed. So how will you do it?
Gear.
Gear, any other V welt, right?
Yes, sir. Be well. Yes, sir.
V welt or gear. V welt will be a bit lossy, so gear would be nice. So we'd have a gear ratio of how much? Tell me. How much will be the gear ratio? This is 350 RPM. This is speed 1 and speed 2 is 3500 RPM.
10 times, around 10 times.
10 times. So the bigger gear will be attached to the lower speed and the smaller gear will be attached to the higher speed and the ratio will be 10 is to 1, right? So if it rotates one time, this gear will rotate 10 times.
Yes, sir.
Let me, so you have a motor here. This motor is to rotate at 350 RPM, right? So you will attach a gear. Gear is obviously not this. Gear is a bit of like this, having some teeth. Sorry for the diagram. And you will have a smaller gear here. So the diameter, if it is D1 and this diameter is D2, so D2 by D1 must be 10 is to 1, right? And then we will have a fan attached to this. So this will rotate at 3500 RPM. Is it not so? So if it rotates one time, this gear will rotate 10 times. So we'll have a magnification of speed. So is a gear not required then for interfacing such things? So we have a V welt also. This V welt is mostly seen, as per my time, it was mostly seen in some atta chakkis, I think. Do you has anyone seen it? Anyone noticed it?
Yes,
That
sir.
when you go to grind your what are they called?
So wait.
Atta,
Yes, sir.
yes, wheat, that solid thing into a powder form. They use this V welt, right? So I used to see this V welt, and then just a second. Yeah, some error happened. Is it visible?
Yes, sir.
It's hanged actually, not responding. So I need to restart. Just a second, give me some time. Yeah. No. Okay. So one is a gear, the next one is a V belt, another one is it's like a rack and pinion. So there are many more interfaces, out of which I have pointed out three. So gear is mainly used. V belt is also used in some applications, in many applications actually. But this V belt causes wear and tear of the belt. So mostly maintenance is a major issue here. And then we have uh, some applications which need the
Sir,
rotational motion
maintenance
to,
will be for gear also because it is a moving part, right? Maintenance will be a gear.
yes, 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 definitely. But gear will be a much lesser, and the coupling is very tight for the gears. Coupling is very tight. I'm facing some issues with this PPT. Okay, so the gear, the coupling is very tight. Here you see the coupling is not very tight. So there can be slippage also, na? There can be slippage. Is it not so?
Yes, yes, sir.
There can be slippage, right?
Mm.
If it is much more loaded, then some slips can happen. Right? But uh, there are some applications where a rotational to translational motion is required. As in the case of this, see, the motor is rotating on its own, right? But the motion is happening from left to right, right to left. So that's called a translational motion, where the motion is linear, but the rotation of the prime mover is clockwise or anti-clockwise. So there also you need an interface. In the case of a lift, what interface you have? You have something called as pulley. Is it not so? And a gear and V belt can give you, sorry, the gear and V belt can give you interface from rotation to rotation, right? See, in the IC vehicles or electric vehicles, what do you drive? You drive a wheel from a prime mover. So that is rotational motion to rotational motion, right? In a V belt or this Atta Chakki also, you have rotation to rotation. But in a lift, you have a motor driving a lift which is going up and down. That is linear motion. So these two types of motion are required actually. So is it okay now? Okay, so we will continue this in the next class because this is a completely different thing. So please tell whether you have any doubts for today's class. It was very much detailed. This the four quadrant operation. Then we understood the four quadrant operation in a lift, which we use every day. And finally, we are done with the types of interface mechanisms. Next class, we will do some numericals also on the interfacing with the rotational and translational motions. So that will be a complete new class. So any doubts for today?
Sir,
Yes.
sir, is there any sign convention that will use clockwise as negative?
Yeah, for anti-clockwise, we have the positive sign attached to it. For the negative, for the clockwise, we have a negative sign. This is a mean convention as far as drives is concerned. Anti-clockwise, positive, clockwise, negative.
Sir, with respect to motor only, sir.
With respect to rotations, right?
Rotation of the motor.
Yes, rotations. Anything more? Okay, so we can meet.
Sir?
Yes.
Sir, in the back-to-back PPTs, so there was a BLDC. So what was that?
Back to PPTs.
So in the total, so when the motors are divided.
AC
Yes,
motors.
sir.
Okay.
So
So
what was that, sir?
BLDC is called brushless DC motor. It is actually a AC motor which has a characteristics of a DC motor. That is why it's a BLDC motor. Right. So we will understand how it works later. But it is an AC motor. Keep it mind, it is a AC motor. Many people see, if you go in the market, they will obviously call it a DC motor, right? But it's not so. There are technical reasons for it. There are technical experts call it a AC motor, right? So BLDC is a AC motor. It is most preferably a synchronous motor. Why is it synchronous? Because synchronous, just a second. So synchronous is what? The field is rotating at some speed, ns, and the rotor is also rotating at some speed, right? So if ns is not equals to nr or nr is not equal to ns, we call it asynchronous, right?
Yes, sir.
If ns is equals to nr, we call it synchronous motor, right? Now in synchronous motor, who is following who? Is the stator which is producing a rotating magnetic field, or the rotor which is really rotating, which is following whom? In a synchronous DC, in a synchronous three-phase motor, what happens? The rotor is following the stator, right? The rotor is trying to follow the stator. But in BLDC, the reverse happens. The stator is trying to follow the rotor. The stator field, actually, not the stator, the stator field. The stator field, magnetic field, is trying to follow the rotor motion. So this is also a synchronous AC motor. But this is rotor is not trying to follow, the stator is trying to follow the rotor. So BLDC, where will you find BLDC? You will find it in the electric auto rickshaws. Most probably they use 2 kilowatt systems. So at the back of the rickshaw, you will find a Chinese BLDC motor. It comes at 12,000 rupees along with the controller, and that is fixed up at the back side, and the controls are in your hand. So if you just drive it, it will just go. Its cost is 12,000 rupees. It comes, the cost is 12,000 rupees, but it is not the latest price. It was, I heard it around 3 years ago. Nowadays, after this corona, the prices must have increased. And anyways, so it is 2 kilowatt motor. So it is enough to take care of 4 to 5 people. To pull one person, how much watt of motor do you need? You know it? An average person, if you want to pull him using an electric motor, how much wattage do you need?
5
5 watt?
5 kilowatt.
5 kilowatt. See, in electric auto rickshaw, they use 2 kilowatt, right? In electric auto rickshaws, around 5 people are there.
Okay. 500 watt then.
No, it's around 200 to 250 watts. Mostly
Okay.
200 watts, right? So if your electric vehicle is carrying only 200 watts of motor, you don't have to have a license for it. So that's a good convention. 200 watts per person. So 200 watts per person into 5 persons will give you 1 kilowatt. And the weight of the auto If you have to pull it, then another say around the hardly 80 to 100 kgs. So it is approximately 1.5 to 1.8 kilowatt of power of motor you need. So approximately they give 2 kilowatt of motor so that you can have some speed also. It runs at around 40 kilometer per hour, that electric auto. Right. So that is the average requirement for a person to be pulled by an electric motor. Right. Isn't it interesting? Electric cycles do carry a BLDC motor also, that Hero Electro. Have you gone through this example of Hero Electro? That comes at around 17,000 rupees, 17 or 21,000 rupees. It carries a BLDC motor inside it. Right? That is called an in-hub motor. It carries a BLDC motor of 200 watts. That's why the cycle can take you up to good speeds, around 30 kilometer per hour also. Okay, so let's meet in the next class. Any doubts for now? Any doubts?
No, sir.
Okay, let's wait.